Hey everybody, John with HillCo here. A while back when we did our last, I believe it was our last building update, where I showed you a quick sneak peek of our 3D printing operation here at HillCo. And so I'm going to give you a quick tour of that right now. So I'm going to turn the camera around and give you a look. Alright, so this is Ben's fancy high-power computer here where he does all his great design work using Fusion 360 to design and develop the models that we use for 3D printing. We'll describe the 3D printing process here in a moment. He's always got something he's working on here, measuring something up, and we don't just use this design office for 3D printing either. We're using it for product design, generating CAD drawings of all kinds of stuff that we make here or have made for us. And so very important work goes on in here. This is a recent addition here, having Ben on board here as our CAD drawing and 3D printing guys. Just opened a lot of doors for us, allowed us to really take control of our own design and again, product drawings and things like that instead of relying on other people, since I don't personally have the capability to do that kind of thing. So, alright, so here is where all the magic happens. Here's Ben.
Howdy.
Ben, how many 3D printers do we have in here?
15, I believe.
15 3D printers. So all of our print, for those of you, I know we have some customers out there. Some of you folks may do some 3D printing stuff yourself. So all of these are Bamboo brand 3D printers. Bamboo is a company that just came on the market here about a year or so, a little over a year ago, I believe it was, and really kind of taken the market by storm with some new technology and some new designs in 3D printing. Really, really cool stuff. So we have the X1 carbon model here. We have 4 or 5 of those. I guess we have more at Dad's house too, don't we? At Kurt's house. We probably have half a dozen of the X1 carbons. And then we've switched more recently to these P1P models here, which work pretty similarly for what we do, but just need a little bit of a stripped down version, quite a bit cheaper for us to buy. So it's allowed us to scale up production and scale up our number of machines for a lot less money. And this is a more recent model here called the P1S, which is kind of the same as the P1P, but has an enclosure, which is not something we really need for our work here, but just kind of we thought we'd try one out anyway. So while we're talking about 3D printers, these 3 models up here all have a component called the AMS, Advanced Material System. I believe, is that what that means,
Yep.
Ben? Yep. And so as you can see, we can print multiple colors with the same printer. So it's feeding that filament, which I'll show you the filament plastic here in a second. But it's feeding multiple colors of the same product in, or can feed them in. So it doesn't feed it all at once, it just does one at a time. And so, but yeah, if you want to print something multicolored or just have several different rolls and the flexibility, maybe sometimes we want to use up some rolls, so we can put multiple rolls of the same color in the machine and set it up so that it uses one roll up at a time if we got some partial rolls to use up. So, for those that don't know how 3D printing works, we have a product called filament here, which is this roll of plastic, kind of a string here, if you will. And it comes in a number of different. You can get this in many different types of plastic. Very common is one called PLA, which is I couldn't tell you the long name of it, but the PETG is another one. There's many different types of plastic. You get nylon, you get ABS plastic, but basically what the machine does is it feeds, as you can see right here, we have the roll sitting there, and it feeds the plastic through this white tube and down into this extruder head, and that heats up and is running, what, Ben, about 250 degrees most of the time? That's
majority of the time, 250, 260.
Fahrenheit temp, somewhere in there, or is that's a Celsius? That's a Celsius, so it's actually probably more like 400 degrees Fahrenheit. So it's heating and melting that plastic and making layers here. So as you can see, this one here is printing parts for our dripless honey valve, and so these are the support pieces. This part here he prints on an angle. You can kind of see that part's at an angle. It's going to be extending that part up more like this, but that printing on an angle, and Ben is a real wizard with this kind of stuff and figuring out the best ways to print things and to get maximum strength and maximum durability or maximum print quality. And so with this particular part, he decided that we need to print that on an angle. So all this stuff you see on the outside here is support material. So that's the material that's going to get broke off and thrown away, apart from the real part that we're actually using. So it works kind of like, if you're familiar with CNC, it uses CNC technology, computer numerical control technology, and so you have your axes up and down and side to side. On this model here, the plate moves up and down, and your print head there, your extruder is moving all around and printing one layer at a time. So one of the things Ben does there on the computer is when we have a 3D model, you have to use a program called a slicer, which takes that 3D model and slices it into thousands of individual layers. And then your 3D printer, that print head just keeps going layer after layer after layer. So it's doing a single layer on all these individuals. This print here has, what, 7 or 8 parts on the same plate. And so it's just printing one layer at a time. You can see it there as it's moving and doing, so it's doing a layer here. And depending on what layer is doing or what particular piece is doing, sometimes it moves faster or slower, and you can change the print speeds on it. That's one thing we love with these bamboo printers, is they print quite fast compared to a lot of other home 3D printers. One of the big breakthroughs they've made, Ben keeps most of these machines on these little shock absorber things here. They do tend to rock around some, as you can kind of see there. But anyway, so here's lots of rolls of filament. We keep stock of some different colors. Black is definitely the most commonly used, but then we also use a lot of the clear PETG product for making these dripless valves that we talk about a lot. So this valve here is something that, again, we've talked about quite a bit on our website and in videos, that it's a dripless honey bottling valve. And so we use, this has kind of been through a number of different iterations over the past few months, but the main body here currently is made from stainless steel. It's actually a stainless steel pipe T fitting. And then the plunger piece, as you can see in the top there, that goes up and down to let the honey out, that is stainless steel. The clamp here for the sanitary fitting, stainless steel, and then there's a spring inside that controls the up and down movement of the handle here, brings it back to closed. That is stainless, but the rest of these parts are all 3D printed. So these black handle pieces, this pivot piece here, this black pivot piece, and these other white plastic pieces. There's some additional internal pieces in these fittings here for how it mounts onto the machine, onto the bucket or tank. Those are all printed from food grade, 3D printed from food grade plastic, which again is some of what he has printing here. These clearish white looking plastic pieces, or down here is one of the pieces that threads in the top. That's the top piece, Ben? Yeah, it's the top piece of the valve here, so that would be this white part right here in the top. Is printing. He's printing, what, 6 of them right there at a time. So Ben, how long does this print run here?
12 hours.
12 hours. Okay, so to print those 6 parts,
maybe more like 9.
Okay, 9 hours. Okay, so even though we're just talking about how relatively fast these 3D printers run compared to some other machines, some cheaper models or whatever, or some older models, they still take quite a long time. And so we're kind of learning as we go here. We find in some cases that the 3D printing is really good for production if we have enough machines and can keep up, but there's certain times when we have to look at other options too, because it just takes too long to physically print that part. So another thing that so in addition to the valve that we just talked about here, another thing that Ben came up with recently is these 3D printed controller boxes, controller housings that go on our Enduro, Minimax, and Ultramax honey extractors. So we used to have these made in stainless steel for us, which worked well, but we had to have them made outside. We don't have the capabilities to bend and to make those boxes ourselves. And so what this allowed us to do by 3D printing, it number one allowed us more flexibility in the design. So Ben came with this cool hexagon shaped box here. By adding in some design like this model fits our Minimax or Enduro, so there's no red e-stop button on top, so we just have this hole plug in there, so it allows us to print one box that fits all 3 machines. If we ever make a design change in the hole mounting of how it mounts onto the top bar, we can always make that change very easily. This has allowed us also to add more ventilation holes to these boxes to keep these controllers running cooler and lasting longer. So it's something we can make in-house. We can control production of it, control design of it much more closely. We can make rolling design changes. So that's some of the things that this 3D printing capability has done for us to make it really easy And for the record, by the way, in case anybody's wondering, going to this plastic box versus the stainless steel actually didn't save us money, and I think it actually maybe cost us a little bit more, frankly, to make them out of the plastic. So it wasn't about cheapening the machine down, it was just about getting more control over production design, and it's really worked very nicely. So, and you see how we have multi-color here, we got yellow and we got black. That's something that Ben is able to do using these 3 machines up here with the AMS system on it that allows it to print, and it can switch by changing the filament in that extruder. It heats up and draws the filament out of that extruder. So it starts at black, for example, and then once it gets done with that layer, it's ready for the yellow layer. It brings the yellow filament in and feeds that through until it's done and keeps switching out. So that does add, doing that multicolored thing certainly adds some time to the production, because it takes a lot of time to, again, heat and reheat and draw out the filament and purge the color and whatnot. But we really like the look of that yellow. It just really sets it off, that yellow on black. So anyway, this is also, we've talked about with Lewis, my son Lewis, how we print some 3D printed beehives. Ben has done a great job coming up with a new design of that. So we'll be probably doing a video with Lewis here at some point in the future, showing that off. That's kind of, he'll be in charge of printing printing those. But Ben has added some design features to that too. So anyway, Ben, am I missing anything important? Got it pretty well covered. So yeah, we're gonna keep again. So in addition to these 15 here, we have a total of probably 5 or 6 others. 4 or 5 others. Okay, so maybe we have about 20 machines total between our different other places in this room here. But it gets so hot in here. So again, we talked about how hot this extrusion process is here, about 400 degrees at the end of the nozzle there. And so this room got super, super hot, even though it was climate controlled. So we had to get a additional air conditioner unit in here to help keep it cooler. So it's around about 71 degrees, nice and cool. I'd say, what was it, about 98 at times in here, Ben, before we put that in. So it's just super, super hot to be in here working. So anyway, so that's that. Just a little quick tour of the 3D printing operation. Hope you liked it. Thanks for watching. Have a great day.